Now, if we want to calculate velocity vector, which I will represent here as x derivative, it will also be a vector space in third dimension. So its derivative will be like d by dt xt. We are simply differentiating the position vector. Similarly, for acceleration, what we do is we take the derivative of velocity vector. So it would be similar, and it would be like double derivative of position vector. Next, if we want equation for computing position, we are writing a general equation. So let's take an example for writing this general equation. Let's take a simple example, driving a car. So at t equals to 0 second, when the car is in rest, speed is 0 kilometer per hour. Let's say after some time, t equals to 1 second, speed became 2 meter per second, and after some time, t equals to 2 second, speed is 4 meter per second, and so on. So you can see a pattern: 2 meter per second, then 4 meter per second. So at this point, car start acceleration, and you can see that acceleration is constant because it's increased by a value of 2 meter per second. After that, like we have 0, then we have plus 2, plus 2, plus 2. So it's accelerating with a velocity of 2 meter per second square. So yeah, it's adding at like 246 meter per second. In that way, we assumed a constant acceleration. So if we have to write it in general differential equation terms, we can say at a particular time t, the velocity is this, which is equals to the initial velocity plus the velocity in between time 0 to t, which is integral of acceleration. What is this tau term? It's a dummy variable. To not to get confused with this t, so that's why we take, let's suppose we have 0 second, 1 second, then go on. Then there we encounter this in between tau second and the last t second. This is the in between variable, dummy variable, while we are moving from 0 to t to avoid confusion in the formulation. So we can represent velocity as this. Y integral, we know if we have position x, if we want velocity, we will differentiate it with respect to t. and we want acceleration, we would double derivative it with respect to t. As we said previously, if we want to get reversed, like from acceleration we want velocity, or from velocity we want position, we do integration. So yeah, we are integrating our acceleration to get the velocity at time t, and through Newton's second law, we know force over mass into acceleration. So yeah, we can write it as this in terms of time. So we can replace it in our first equation. So it would look like this. So why we are doing this? Why we're calculating the equation for position and then orientation? This is required for designing the Simulink model for helicopter. This is the equation of velocity at point time t for a particular position. So yeah, we will also calculate